Okay, before we can actually apply this, I need to mention something about the boundary curve. So let's say this is the region R. We need to have a counterclockwise orientation, which means something like this. Now, what happens when you have a region like this, but you take out a hole like that? Now, this is the boundary curve. This is part of the boundary curve, but also this is part of the boundary curve. So there's really two different boundary curves, or two different parts of the boundary curves. So how does this work with orientation? Well, the idea is that the outer curve is going to have clockwise or counterclockwise orientation, but you need to have the inner curve have clockwise orientation. So the outer curve has counterclockwise orientation, the inner curve has clockwise orientation. And we talked about this a little bit when we were doing line integrals, but here is one way to see this. Here's one way to consider why these are actually the same orientation. So the idea is the following. So let's say you are walking along the path in this direction. Let's say you are walking along the curve in this direction. Your head is sticking up out of the screen and you stick your left arm out. Now your left arm is pointing over the domain. This is called the positive orientation. Okay, that's why I like the counterclockwise orientation. Essentially what you're doing, you are representing the vector 0, 0, 1, the k vector. Okay, and as you go around the boundary, if your left arm is sticking out and it's sticking over the region, then you are walking in the positive orientation. Okay, this is just basically the right hand rule. Now, if you're on the inside boundary and you do the same thing, see, if you were to walk around the inside boundary going counterclockwise with your left arm sticking out, your left arm would be sticking out this way. So let's do this again. So you're walking along the outer boundary with your head sticking up out of the screen and your left arm sticking out this way. If you go, your left arm is always pointing inward. It's pointing inward over the surface. On the other hand, if you walk in the counterclockwise direction on the inner boundary and you stick your left arm out, your left arm is not going to be pointing over the surface. It's going to be pointing over this hole, or not. It's not going to be pointing over the region. It's going to be pointing over the hole in this region. Remember, this part of the region, or this part right here, is not included in the region. So if you walk around counterclockwise with your left arm sticking out, your left arm is not pointing over the region. On the other hand, if you walk clockwise and stick your left arm out, then your left arm is pointing over the region. So if you want to use Green's theorem, you need to make sure that the boundary curve, the outer boundary curve, has the counterclockwise orientation when you're computing this line integral. And all of the inside boundary curves like this one, or maybe if there's a curve like this, they all need to have the clockwise orientation. And again, the reason is just because we want to take the positive orientation. Positive orientation meaning the one that is consistent with the right hand rule.